Hey there, have you ever really stopped to think about how the warmth from a campfire actually gets to your hands? Or how a pot of water on the stove gets boiling hot? It feels kind of obvious, right? But it's actually a super fascinating puzzle of energy on the move. So, today, let's break it down and look at the three big ways heat gets around in our world.
Okay, so take a look at this. We've all seen this a million times, but think about it. The flame is only touching the bottom of the pot. So how does all of the water get hot? Well, the really cool part is that it's not just one thing happening. All three types of heat transfer are actually going on in this one single picture.
So before we crack that puzzle, we need to get one basic idea straight. Heat isn't really a thing. It's just energy, and it's on the move. And it follows one super simple rule. It always flows from something hot to something colder. Always. The cooler thing soaks up that energy and starts to warm up.
So how does that energy actually make the trip? Well, it has three main methods of travel: conduction, convection, and radiation. Let's dig into each one. All right, first up we've got conduction. You can think of this as the touchy-feely method of heat transfer. The name itself is a pretty big clue. So yeah, the absolute key here is direct contact. Things have to be physically touching for conduction to work. The heat energy literally gets passed from one molecule to the next, kind of like a vibration traveling down a line of dominoes. And we can see this perfectly in our examples, right? The hot stove burner is touching the bottom of the pot. Boom, that's conduction. It's the exact same reason a metal spoon gets super hot when you leave it in a cup of tea. The heat just conducts right on up the handle to your fingers.
Okay, let's move on to our second method. Now we're shifting from solid objects touching to things that can flow, like liquids and gases. This is convection.
Now this is where it gets really interesting. With conduction, the energy just got passed along. But here, with convection, the actual hot particles, the molecules of water or air, they physically get up and move, carrying their heat with them like little energy taxis. Let's look back at our pot of water. The water at the very bottom gets heated by conduction from the hot pot. When it gets hot, it gets less dense, so it rises up, and the cooler, denser water from the top sinks down to take its place, where it gets heated and rises too. This whole circular motion is called a convection current, and it's what heats the entire pot. It's the exact same idea that makes a hot air balloon fly. And that brings us to our third and final method, which is completely different from the other two. This one is radiation. Okay, this is where it gets really cool. Radiation doesn't need any particles or any contact at all. Nope, it sends heat out in the form of invisible waves, kind of like light. And the most mind-blowing part? It can travel through the total emptiness of space. Think about feeling the warmth of a campfire on your face, even when you're several feet away. The hot air is rising up, so that's not it. Nothing's touching you, but you still feel the heat. That's radiation. And of course, the biggest example of all is the sun. It warms our entire planet by radiating heat across 93 million miles of empty space. Pretty amazing. All right, so we've met our three types of heat transfer. Now let's put them side by side so we can really see what makes each one unique. This table really sums it up nicely. For the mechanism, how it works, conduction is all about direct contact, convection is the movement of fluids, and radiation uses those electromagnetic waves. Now for the medium, what it travels through, conduction and convection both need some kind of matter to work. But radiation? Nope, it needs no medium at all. And that directly affects their speed. Conduction is pretty slow, convection is faster, but radiation is the hands-down winner, moving at the speed of light. So, knowing the theory is great and all, but how do you actually spot these things happening around you? Well, turns out it's actually way easier than you might think. Here's a super simple checklist for you. First, just ask yourself, are things touching? If the answer is yes, you've got conduction. If no, ask the next question. Is heat moving through the air or a liquid? If yes, that's convection. And if the answer to both is no, and you've got heat jumping across a gap, then you are looking at radiation. It's a great little mental tool you can use anytime.
And just remember, it doesn't matter if it's conduction, convection, or radiation. This one simple rule is always true. Heat is a one-way street. It always flows from hot to cool.
Okay, let's finish up with one last thought to tie this all together. So we know the sun warms your face through radiation, and a blanket keeps you warm because it traps a layer of air, stopping convection from stealing your body heat. So what about when you touch a piece of ice? That cold feeling you get is actually heat rushing out of your hand and into the ice. So, based on what we just learned, which one of the three is that? Well, the answer is right at your fingertips. Thanks for tuning in.